All right, this is going to be a mix of both review and some new stuff. So we've got a triangle of sides 8, 15, and 17. And usually in problems like this, they'll tell you it's a Pythagorean triple. They might ask you to verify it. But 8 squared plus 15 squared equals 17 squared. That actually is true. I'll leave it to you to verify it. But if that is true, and when it is, we know this has to be a right triangle, which means all our right triangle rules apply, including the most important of which is sine, cosine, and tangent. So sine is, if I'm looking at this angle right here, which two sides are we talking about? That's right, opposite over hypotenuse. So in this case, it would be the 8 over the 17. If we're looking at cosine, which two sides? That's right, it would be adjacent over hypotenuse. So 15 divided by 17. And then tangent, which two sides? That's right, it would be opposite over adjacent. So 8 over 15. Up until now, usually we're given the angle and you've got a side and you're missing a side, and you use the relationship between those to figure out the missing side. In this case, what we're going to do is we've got the sides and we're going to figure out the angle. So I'm just going to use cosine to start with. So if I'm looking at cosine for this angle, so the cosine of that angle, which I'm going to call, just going to call it angle A. Okay, we'll call this triangle ABC. The cosine for angle A is going to be adjacent over hypotenuse. Is going to be 15 over 17. Okay, 15 over 17. And I'm going to get my calculator out and look that up. And 15 divided by 17 is this. And that's 0.8823, so roughly 0.88. And what I normally do to figure this out is I probably go to a trig table. And once again, we're looking at cosine, which is the middle column, and we're looking at 0.88. And so 0.88 here, if I've got a big trig column, is here. 0.88 for cosine is, it's over here somewhere. 0.88 looks like it's about between 28 and 29 degrees. I don't know if you can see that or not, but it is. If I've got kind of a smaller trig column, it's a little more obvious. So 0.88 for cosine is going to be roughly right there. So a little between 20 and 30, 0.88 between 20 and 30. So maybe 28 degrees. So that's the old way to do it. So if I was going to do it that way, using the big table or the other table, I say, okay, that's true. Then A, the measure of angle A, is 20, we're just going to say 28 degrees, kind of guessing. The other way to do this is with the calculator, and I'm going to do it just slightly differently. I'm going to say, okay, let me do it with tangent this time. So I'm going to do the tangent of in fact, I'm going to do the tangent of angle C. I'm going to change colors too so you can see what I'm doing here. Okay, we'll do it with blue. Okay, so the tangent of angle C. So the tangent of angle C. Now I already know what angle C is. If this is 28, this is going to be 90 minus 28, or about 62, I think, if I did that right. Okay, so the tangent of C is equal to 15 over 8. And then the question is, well, can I get that number out of the calculator rather than looking it up in the table, in the column, and working backwards to the angle? And I can. And I'm going to do a brief aside about inverse operations. Okay? So inverse operations are really important. It's what we use in algebra, although you may not remember it. If I've got 3 times x equals 12, our inverse operation for that is division. Multiplication and division are inverses. So 3 times and 3 divided by cancel each other out, and I'm left with x there. Okay? When I'm minusing something, the inverse operation is adding. And so notice I'm also left with x there. And whatever I do on the left side, of course, I've got to do the same on the right side, which is why whatever inverse operation I do to this side, this is what I'm going to put in my calculator. I think where it becomes a little more obvious what I'm about to do is with square. So if x squared is equal to 25, the inverse operation of that is square root. So the square and the square root cancel each other out because they're inverses of each other. And I'm just left with an x. I don't really have to think about it. I just know those two cancel each other out. But on this side, this is what I put in my calculator. Okay, we're going to do the same thing here. The inverse operation of tangent theta is something called arctan, or on the calculator it often shows up as tan to the -1. Okay? And so I'm going to do it to one side. This is going to undo it. I'm going to be left with theta on this side, or x, or whatever I want to call my angle, just the way I'm left with x right there. Okay, so I'm undoing it. But because I did the tan -1 here, I've got to do it on the other side to keep my algebraic equation balanced. All right, so now I'm going to actually do this in my calculator. So I'm going to do tan -1. So in this calculator, you get shift and tangent. You notice a little tan -1 there. And then I'm going to do 15 divided by 8. And then I'm going to hit equals. And assuming I am in degrees, I get my 61.92. So almost 62, which is what I was expecting, despite the second, I think I said 52 a minute ago. We knew this, if this A was 28, this other one, the C, had to be 90 minus 28, or about 62. But if we do it this way as well, essentially we found out that if we do tan -1 of 15 over 8 in our calculator, it gives us this number. So this is exactly like looking 15 divided by 8 in my calculator, going through the 15 divided by 8, what that number is, looking it up in the tangent column of the trig table, and then saying, okay, what was that degree? And then I can check myself. If I do tan of 62, if it's not equal to this fraction or close to it, it's wrong. Same thing here. If I do cosine of 28, it should come out to roughly what 15 over 17 is. Okay, I'm going to go through a couple of problems real quickly. So in a word problem, how this might show up. Where is it? Okay, I've got a word problem which I'm going to let you read on your own. I'm going to put it on the screen for a moment so you can read it. Okay, so there that is. You want to build a roof. You know you want the length or the hypotenuse of the roof to be 4 feet and the rise to be 0.42 feet. The contractor is helping you. You need to know the angle of the elevation from the bottom of the roof to the top. What is the angle of elevation? Okay, so let's draw this out. 4 feet long, 0.42 feet high. This is going to be a right triangle. I could figure out the hypotenuse. This is not asking for it. It's asking for what this angle is. Okay, so if we're using those two, this is opposite, this is adjacent. So we know the tangent of whatever that is. Let's call it, I'm going to call it R for roof. Tangent of R is equal to 0.42 over 4. All right, and now I'm going to take the inverse operations of both sides. So I'm going to say, okay, I'm going to undo my tan. And once again, this can be called arctan as well, and you'll see it written that way on some calculators. Okay, no math required. These are inverse operations. This has to be R. The math required is on this side. When I do the inverse tan on one side, I've got to do it on the other side. So I'm going to do this, and then that's the work I'm actually going to do on my calculator. So shift tan 0.42 divided by 4 equals 5.9 degrees. This is not a very steep roof at all. 0.99, so almost 6 degrees is what that angle is. So this drawing is not very to scale. Kind of a variation of that, which I don't have a picture of, is maybe I give you a, we're building a ramp or something, and we've got a piece of wood that's like 10 feet long. And that piece of wood is 10 feet long, and I've got some blocks here that are each 1 foot, and I'm going to build a ramp such that it's 3 feet. And the question is, what is the angle of this ramp that I've just built? And so it's the same process, except in this case, I'm looking at this angle again, which I'm going to call, let's see, that was called R. I'm going to call this one S, okay? In this case, it's opposite of a hypotenuse, so that's going to be the sine of S equals 3 over 10. And then the same work. I'm not going to show it, but ultimately I'm going to take, this is going to be the inverse sine of 3 over 10. And so we can figure out what that is. And just by looking at this, it's hard for me to tell, but I'm going to guess somewhere between 10 and 30 degrees is what that is. So Shift sine, 3 divided by 10, and 17 degrees is what that would be. 17.45 degrees. So S is 17, and we'll just call it 1/2 degrees. Okay, so pretty steep S ramps go, and you can't quite see that. A couple more problems I want to set up, and then I'm going to do one more and then queue up 2 for you to do on your own. Okay, you've got a balloon on a string. This is basically perfectly straight. I know that's not realistic, but maybe it is. Okay, this is what it reads. String, you tie it to the ground. It forms a 79-degree angle with the ground, and the string is 16 feet long. How high is the balloon? So 16, 79, and the question is, what's the height? So this is an old problem. This is review, okay? This is not using the inverse tangent. This is saying, oh, I've got these two. I'm not going to call that height. Let's call that x. This is the opposite. This is the hypotenuse. Which am I going to use? That's right. I know the sine of 79 equals x over 16. And then I just look that up. I'm going to do sine of 79 is 0.9816. Oops, there's an 8 in there. Equals x over 16. I can put that over 1. I can cross multiply. And because I end up with 1x here, there's nothing left for me to do other than the 16 times that number, which is 15.7, which makes sense. This is very steep. This is almost as long as the string, and that'd be feet. I'm going to set one up, and then I'm going to be done because I'm going a little long. You have, this should look very familiar to you. You have determine the height of a flagpole. You've got a surveying tool that shows the angle of elevation from the ground to the top of the pole is 19 degrees. And the measure from you to the flagpole, it's 90 feet. How high is the flagpole? So this looks like this. 19, 90. I'm trying to find this. I'll leave it for you to figure that out and maybe add you a couple of questions, but that's long enough. Thanks.